Okay. Um, Hello and welcome to the last class of this week. Remember, tomorrow is Veterans Day. We have no class tomorrow. Okay. So that's kind of why I'm pushing through all this. So to make up for the missing time, so you'll have more time to study this weekend. So anyway, tomorrow, no class. I'll talk more about these quizzes. And I'll repeat this once again, and then I want to erase it. So people who aren't here, that's their problem. But in the exam 3 module in Canvas, I've put a breakdown of topics, how many questions, what types of questions there's going to be, and how many there's going to be from chapter 9, how many from chapter 10. Okay. And like I said, I'll talk more about the quizzes that are on MOM right now. However, last night in chapter 10.5, get a new pen. That's dead. We were discussing solving. That's dead. This is not a good night. Solving exponential abbreviation equations. And there was two types. Okay. And I'm going to go over this briefly because I did it yesterday briefly and then get into some other stuff. The first was same base exponential, and that looks something like 8 to the 3x minus 2 equals 4 to the 6x plus 3. Okay, and then you had to break this down into 2 to the third to the 3x minus 2 equals 2 to the second to the 6x plus 3, and then you can go from there. I'm not going to redo that, but you can go from there. We've done that a couple times. This is going to be on one of the quizzes, same base exponential equation, something like this. Get the, look inside, see if you can see the same base. Then we introduced, I guess they're called different bases. Okay, again, these are still exponential equations. So all of these have to do with exponents somehow, exponential equations. What if they have a different base? Well, to make up a problem, let's say we have 7 to the 5x minus 4 equals, I don't know, let's go 55. Okay, something like that. Well, there's no way that you can break 7 into 55. You can't do this as the same base problem. Okay, you can't. So there was two ways we did this. Okay, method number one was just apply the Bra-Bar rule. Okay, and that became log base 7 of 55 equals 5x minus 4. Remember, this is the exponential, and this is the logarithmic version of the same thing. These two equations, according to the Bra-Bar rule, are the same. Okay, and at this point, then we just used our calculator and all the fancy stuff. Log base 7 of, what do I have there? 55. Okay, whoops. Base 7 of 55. Okay, and I talked yesterday that I really almost don't care what you put here. It's 2.5, no, 2.05, I'm sorry. 2.05. But you're not going to use 2.05. 2.05 equals 5x minus 4. Sorry for talking like this. Okay. All of your calculations are going to be done here. You're just kind of writing this thing down just to keep track of everything. The actual, it's not 2.05, it's 2.0593618881. But I don't want to write all that crud down. I'm just going to write down the important part. But then I'm going to add 4 to both sides and do it on my calculator. Okay, so now I have 6.05 equals 5x. So now I'm going to divide by 5. Okay. And I get 1.211872376. That's on my calculator. Well, and I'm in the glitter too. At this point, you go back and read whatever the directions say and tell you how to round. So it's kind of, we're learning 2 things simultaneously. First, how do I solve this problem with different bases? One method is using the Bra-Bar rule. That changes it to logarithmic form, and we can do that on our calculator. The other thing we're also learning is that since you have your calculator, you don't have to put down all the long, stupid decimals here, but you do have to keep them in your calculator and let your calculator do the work for you. So once you get your long decimal answer, then you round it according to whatever the directions were. Is that kind of okay with everybody?
Yep.
Okay. All right. That was one method for doing this. Okay. The other method, same problem, 7 to the 5x minus 4 equals 55, is probably more common. Okay. And that is to take the ln or the log, it doesn't matter, but I like to always take the ln of both sides. So we take the ln of 7 to the 5x minus 4 equals the ln of 55. So, excuse me, same problem, just take the ln of both sides.
Wait, is it 3x minus 4?
5x minus 4. 5x minus 4. I wrote it here, but it's kind of bad here. It's supposed to be the same problem as this.
Got it.
Okay. So the question all you students have to answer is why? Why did he take the ln of both sides? Because once you write this as a logarithm, and remember ln is just a fancy logarithm, you're allowed to use those log laws that we talked about. In particular, you're allowed to take the power out front, but you can't do that until you put a log there or an ln. So your next step is take the power out front, 5x minus 4 times the ln of 7 equals the ln of 55. X, geez. Come on, tell me x. Okay. So now we want to divide both sides by the ln of 7. Okay. Those will cancel out, and we're going to get 5x minus 4 equals, and if you calculate the ln of 55 divided by the ln of 7, well, I didn't show it. Wait a minute. ln 55 divided by ln 7. What do I get? I get 3.341 something. I don't know. I don't care what it is. I'm going to add 4 to both sides and divide by 5.
I got something different when I did that.
ln of 7.
Yeah.
Hmm.
I got 2.05936.188. What was like the same as the first one, I think.
Yeah. ln of.
I
Oh,
also got the same thing as the 2 point.
ln. You know what I did wrong? You don't care. Okay, wait a minute. Yeah, better. Thank you. You know, I did wrong. It was I did the I did the ln of 7 divided by the ln of 55. But anyways, you're right. 2.05 something, something, something. The same thing we got here. Okay, and at this point, it is the same problem as up here, so we don't have to redo it. Okay. Now, I don't know whether to show you a third way or not. I'm going to choose not to. If you want to see a third way, that's kind of slick, but not necessary, stick around after class tonight. If you want to see a third way to solve this problem. Okay. If you're happy with either of these, then that's great. Whichever way, as long as you're showing me your steps, and of course, as long as we get the same answer, I'm happy. Okay, so that's a sort of a recap of what we did last night, solving exponential equations in 10.5. I need to erase the board, okay, because I've got to do more of 10.5. But is there anything up here that anybody has a question on? Okay, then we erase. Okay. So now it's still in 10.5. We're going to solve log equations. And once again, there's 2 types you're going to run into. Okay. The first type is that all terms have a logarithm on them. And the second type is one term is missing a logarithm. Okay. So I'm going to do a couple of problems here, and I'm really hoping, okay, that you guys will stop me if I'm losing you. So right here, what do I mean by one term is missing a logarithm? Well, here's a sample problem. Log base 3 of x plus 1 minus log base 3. I'm gonna have to erase this. Of x equals Oh, what do I want this equal? I'll have it equal 2. Okay. This is a fine example of a log equation. Okay. But one of the terms is missing a log. Everybody's a log. This is a log. This is a log. This is not a log. So what are we going to do here? Well, the first thing we're going to do is use our log laws to condense these into a single log. Okay. Well, now you got to go back to what were your log laws? What were the log laws if you had, okay, I'll do it over here. If you had the log of m minus the log of n on that cheat sheet, on that handout I gave you, if you had two separate logs that were subtracting, how can you condense them? When they become one log, L-O-G, come on, dummy. What are they doing as I condense them? Anybody know?
Isn't it you divide them?
They become division, m over n. So two logs that were subtracting originally can be condensed into one log that's dividing, or a fraction. So over here, here's two logs that are subtracting. These could be condensed into one log that is dividing. Okay, so that's a really good way that we're going to have to know those rules, those intermediate rules on that cheat sheet. Okay, well, now what do? Well, now you apply the bra-bar rule. Okay, because again, when you're stuck and you're in logarithmic form, you cross your fingers, you pray, and you say, hey, maybe if I change it to exponential form, it'll work out for me. So again, applying the bra-bar rule, and remember, bra-bar or bar-bra, doesn't matter how you say it, that's actually a Fosterism, okay? You won't find that in any math book anywhere, but that's Foster's talk for the definition of a logarithm. And that was 3 to the 2 power equals that. So we have this equation, 3 to the 2 power equals x plus 1 over x. And now you just have to solve that. Okay, and of course I'm in the glare. 3 to the 2 power equals x plus 1 over x. Is that better? Yeah, same problem. Okay, so now this is just a basic problem for you to figure out how to solve. So personally, I'm going to call this 9 over 1 equals x plus 1 over x. Okay, because I like proportions. Proportions are really neat. They allow me to cross multiply. So if I cross multiply, I get 9x equals x plus 1. Subtract x, 8x equals 1. Divide, x is 1/8. Okay, and that's basically it. There's a few tricks. Whoops, that was pretty dumb. I shouldn't have done that. 3 to the 2 equals x plus 1 over x. And then it came up like that. And I'm kind of in the glare. Oh, well. So that's essentially, okay, this example is what I mean when I say one term is missing a log. One term is missing a log. Okay, what you did, get this in your notes, is you took the terms that were logged and you condensed it You condensed it using those log laws that I gave you the other day. Now, remember, there's a whole slew of log laws, so you have to kind of know them and know which one you're doing. But because this was a subtraction, they condensed and became a division problem. Okay, in a minute, I'll come back and do a different problem. But if this had been addition, you'd condense these and say these are multiplying together. But I'll do that in a minute. All right, so let's go over here. All terms have a log. I didn't plan very well here. So what if I have, shoot, stupid. What if I have the ln of x plus 2 plus the ln of x minus 1 equals, sorry for the mess, guys, I hope your notes are better than mine, equals the ln of 9x plus 17, minus 17, sorry. And I apologize for making a mess of this problem. But anyway, here's a problem where all of the terms have logarithms. Remember, ln is just a fancy logarithm. No big deal. It's just a logarithm. We're going to do the same thing. We're going to condense the two terms that are together, pull them into one. But according to the log law, I'm going to write it up here and then I'm going to erase it. We had this rule, if we had the log of m added with the log of n, why can't I write tonight? The log of m added with the log of n, you can put them together as a single log, but m times n. That's what the product log law says. I think that's the first one on that handout I gave you. The product. If two logs are being added, you can condense them into one log where the terms are multiplying. So how do we do it here? Well, this is going to become the ln of x plus 2 times x minus 1 equals the ln of 9x minus 17. All right, I've been trying to save this other problem, and I just can't. Okay, so these two ln's, these two logs, got squeezed into a single log, but the two things got multiplied together. Okay, skipping ahead a little bit, this is better written as x squared plus x minus 2. The ln of x squared plus x minus 2 equals the ln of 9x minus 17. All right, well, what do I do now? You drop the log. When you've condensed both sides into a single log equals a single log, then you can drop the logs. You can just simply say x squared plus 2x minus 2 plus 1x minus 2, I'm sorry, equals 9x minus 17. Okay, well, now we have to figure out how to solve that. Okay, it's a power equation. So that means it's probably got to equal 0. And I either try to factor it or use the quad formula. That's your reasoning here. That's what you have to pick up on. You go, oh, damn, it's a power equation, x squared. So make it equal 0. So that's x squared minus 8x plus 15 equals 0. Because if you take away 9x from both sides, x take away 9x is negative 8x. And if you add 17 to both sides, negative 2 and 17 is 15. Okay. And now you use your factoring rules. Okay. And this will become x minus 3, x minus 5 equals 0. Remember AC, but remember this is what I call an easy factoring. Okay, because it had a 1 there, so you could just use the AC values you had, okay, to get x minus 3, x minus 5. When you do that, you get x minus 3 equals 0, or x minus 5 equals 0. So we get x equals 3 or x equals 5. Okay. And this particular problem, both of those check. And I'll show you how to check in a minute. But this is basically the other half of that. Remember I said there are 2 types of log equations you're going to run into. First type, all terms have a log. Second type, I erased one term is missing a log. My first step in either of them was to condense them as much as I could. Use your log laws to condense them. This was 2 logs adding, so I condensed it into 1 log multiplying. Then I multiplied it out. And then the key here was when I have a single log equal to a single log, I can just drop the logs. Just drop them and solve the resulting problem. It's that easy. Before I entertain questions, remember the same base problem? Remember, we were doing the same base problem. And if you had 2 to the 3x minus 1 equals 2 to the 5x plus 7. Remember when we were doing those same base equations, we worked it down to, it was the same base equals same base. And when they were the same base, we just said, oh, we drop the base and we go 3x minus 1 equals 5x plus 7. So we're doing the same thing. When we condense this down into same exponential base equals same exponential base, we drop the base and worked only with the powers. Here, when we have the same ln equals the same ln, we drop the ln's and just work with whatever was inside. Okay. Questions? Anything? I'll put up a couple more and we'll work on these. Give you at least a couple things to practice. You sure? Okay. You might want to put this in your log laws, what we studied last night. But there are certain law restrictions on logarithms. Let's call them log restrictions. When you have the log base b of something, okay, when you have, and good, you keep finding this stupid ass glare. When you have the log base b of something like that, what crap. When you have the log base b of something, okay, There's a couple subtle restrictions that you need to be aware of. The first one probably won't affect you in this course too much. It will be important in future courses. First off, your base, which is your b value, has to be greater than 0 and not equal to 1. So you can't have a base, you can't have a negative base at all. And it can't be a 1 base. That's just a restriction on logarithms. So the base number, the b, has to be positive, but can't be 1. It can be anything else you want. Okay. And if you don't believe me, try and put on your calculator log base -2 of 5 and see what your calculator does. It should blow up because your base can't be negative. Okay, does it? I wonder what it does. I just thought of that. Clear. And they say -2. 5. Yeah, it gave me a big old error. It says you can't do that. Okay. I will not purposely try and trick you with that restriction. However, there's another one that you do have to use, and that is inside this quantity. Inside this quantity, it must always be greater than 0. Basically, it must be positive. Okay. That is going to get us. Let me show you something. Let's pretend that for this problem right here, I got an answer where x was equal to 1. Okay, let's just pretend. Let's, I did this whole problem. I get x equals 1. But wait a minute. If you put it here, you're going to have the ln of 9 times 1 minus 17. You're going to have the ln of -8. But you're violating this rule. You can only take the logarithm of a positive number. This is asking you to take the logarithm of a negative number. Okay, again, I would ask you check that on your calculator. Okay, it should give you a big fat error, the ln of -8. Yep, error again. Okay, so even though x was positive, your answer was positive, when you plugged it back here, it made this quantity negative. But one of the log restrictions is that when you take the log of somebody, that quantity, that parenthesis must be positive. That's a restriction on logarithms. So a lot of times when we're solving these power equations here, okay, and we get 2 answers, one of them might not check. And the only thing you have to do, is take your answer and ask, does it make that negative? Or that negative? Or that negative? Does it make that quantity, that inside quantity, negative? If it does, you throw it out, you reject it. Okay, but if it keeps it positive, even the slightest little bit positive, then it's an okay answer. Here, here, and here. Okay, that's going to come back and bite us a couple times. You might want to add that to your notes from last night under log laws. you might want to take a second to rewrite that while I'm erasing the board. Can I erase this? Everybody's got this restriction copied down?
Yes.
Okay. So number 2 example, log base 4 of x plus 6 minus log base 4 of 2x plus 5 equals log base 4 of 3. Boom, 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 boom. Okay, so I have 2 problems up here. I'm going to put the recording on pause for just a moment. Oh, wait a minute. Okay, first one term is missing a logarithm. Second one, all terms have a logarithm. So this is just like the notes I gave you. Hint, the first step in all of these was to use your log laws to somehow condense these into a single log and these into a single log. So I'll pause right now. Okay, so this first example is a log equation where one of the terms is missing the logarithm. So what I tried to get you to do was condense, put the 2 that had logs, put them into 1, but these are adding. So 2 separate logs that are adding can be condensed into 1 single log that is multiplying. And that was that product rule for logarithms off that worksheet. 2 separate logs that are adding can be condensed into 1 single log where they multiply together. And I just went ahead and did the multiplication. X times X, X times 6. Now, the next game, after I condense them, is to apply the Bra-Bar rule. Okay, which is 2 to the 4 equals that mess. 2 to the 4 equals that mess. Okay, and now you start cursing all the math gods because this is a power equation, and that means you need to make it equal 0 and either use the quad formula or factoring. So to make it 0, this is 0 equals x squared minus 6x minus 16. 2 to the 4th is 16, so I subtracted 16 from both sides. Okay. Using the AC, this factors as x minus 8, x plus 2. Again, I'm skipping steps, but I'll be happy to show you how I did it. But again, this factors. AC is negative 16. So what times what multiplies to negative 16 and adds to negative 6, negative 8, positive 2. And this gets us our answer of either x equals 8 or x equals -2. Now, going back to the original, if x was 8, that's positive. That's positive because 8 minus 6 is 2, and it's okay. So 8 appears to be okay. But -2, when we put it there, we'd be doing the log of -2. Can't have it. Instantly rejects. Even if you put it there, you'd have the log of -2 minus 6 is -8. The log of -8. Can't have it. So the -2 part rejects. Okay. And your solution set is only 8 in this case. Again, if you don't reject an answer, at worst, it will be -1 point. There's a lot of work in this problem. There's a lot of steps that you had to do. Maybe this is a 5, maybe a 6-point problem. I don't know. Okay. So the worst, even if you don't reject it, the worst you'll do is lose 1 point, but you'll get the rest of the points. So don't panic over rejection. Unless you're a guy, then you always panic over rejection, but that's another story. So that's solving a log equation where one of the terms is missing a log. Questions about this problem or anything I said about this problem? Okay, moving on to the next problem. This is an example where all terms have a logarithm in it. But the first step was always condense. Okay, so right here, we have two separate logs that are subtracting. According to our cheat sheet, those will be condensed into one single log where they're dividing. First number goes on top, second number goes on bottom. Equals log base 4 of 3. So we condensed these two separate logs into one single log. Now the game here was drop the logs. Okay. As long as you have one log on the left side, one log on the right side, you can drop the logs. Okay, let me pause for a second. I need everybody's attention for just a second. Okay, what students do is they go, oh, this is where all the terms have a log, and I know I can drop the logs. So they just drop the logs. You can't do that until you've simplified the problem into one log on one side, one log on the other side. And then you can drop the logs. So you must do the condensing step. You must do that first. Same thing up here. You must do the condensing step first before you apply the Brouwer rule. Okay. All right. So anyway, we'll drop the logs. So we have this x plus 6 over 2x plus 5 equals, I'm going to cheat a 1 under the 3. It equals 3, but remember, I've got this passion for proportions, so I always cheat 1 underneath so I can cross multiply. On the last test, we also had proportions, and some people really screwed up on these. Okay, I hope you had a chance, but remember, I hope you had a chance to look at your notes. But when you do a proportion, you cross multiply and you have 3 times 2x plus 5 equals 1 times x plus 6. you have no more fractions. You still have an equation, but your equation doesn't have any more fractions. And that's kind of important. People really, really got confused on how to cross multiply with a proportion. All right, so this is 6x plus 15 equals x plus 6. So what is this? 5x equals -9. X equals -9/5. I think I did that right. Okay. 6x, take away x is 5x, take away 15 is 9. Okay, this is a little tricky. It's negative. Do I reject it? No. You don't reject something just because it's negative. You reject it if it makes this quantity negative. Okay, that's really important. So in your own mind, okay, this is what? This is approximately -2. Think about that for just a second. 9/5 is about -2. Is -2 plus 6 negative? No, it's safe. Is 2 times -2 plus 5 negative? No, it's safe. So even though x was negative, it still is an okay answer. It still checks. So our solution set for this problem is -9/5. It's not that x is negative. It's what does x do to the quantity? Does it make that quantity a negative value? Now, if you don't like my estimation skills, if you don't like the way I said, yeah, that's around -2, and you plug it in there, then go ahead and use your calculator to do -9/5 plus 6. It doesn't matter. It's okay. But you must convince yourself one way or the other that that is positive and that is positive. So there's our answer. Okay. So pretty much that's about 90% of chapter 10.5. Okay. I want to move on to a new topic. Does anyone have a question on any of the solving exponential equations or solving logarithmic equations, of which we have 2 of them right here? Any questions at all?
So just when it's a negative equation, we divide them?
If the 2 separate logs are negative in between or minus in between,
Mm-hmm.
then when you put them together into one log, yes, you divide them.
Okay.
But if the 2 separate logs were addition and you put them together into one log, you multiply them. X times X, X times 6.
Okay, that's always.
Always, yes.
Yeah. Okay, great.
Okay. Anybody else? Going once. I don't know if anybody remembers Mr. Ed. Okay. The talking horse. Oh, Wilbur, once, twice, 3 times. We're out of here. I guess I'm too old. That was the good old days, you know, make America great again. Have a talking horse on TV. I guess it's better than a talking ass in the White House, but oh, who said that? Not me. Okay. All right. Way back at the beginning of chapter 10, I'm pretty sure it's 10.1, we talked about inverses. And I gave you a list of steps to find inverses. First was replace f of x with y. Secondly, we swapped, switch all x's and y's. Third, we solve for the new y value. And fourth, we replace y with f inverse of x. And that notation shows that my new formula is the inverse of my original formula. And there's all kinds of things we were able to do. This swapping allowed me to graph it inverse by swapping ordered pairs, x's and y's. Okay, there's all kinds of phenomena that we talked about here. So you might want to go back and check your notes. And let's start with this example. Suppose I gave you f of x equals x over 2 minus 7. I want you to find f inverse of x. Okay, pause this. So we write it as y equals x over 2 minus 7. We swap the x's and y's, so x equals y over 2 minus 7. And then the step down here is the most important step. How do I get the y alone? How do I solve for the new y? How do I get that thing by itself? And that's where your skill comes in, because every single problem is going to be a little bit different. Now on this one, it's pretty easy. If we add 7 to both sides, okay, and then if we multiply by 2, or cross multiply by 2, whatever, multiply this side by 2, this side by 2, we get 2x plus 14 equals y. So we write this as f inverse of x is 2x plus 14. Okay, so this function is the inverse of this function. So whatever this function does to a number, however it changes it, because remember, that's the basic idea of a function. It changes the value of a number. This takes that changed number and turns it back into the original number. That's that. Well, okay, what if I gave you this? G of x equals 3 to the x plus 1 minus, well, I'm going to leave it here. 3 to the x plus 1. We'll make it easy for now. We'll start with an easy one. And I want you to find G inverse of x. Okay, so I'll pause this. I'll show you how. This is brand new, but I'll give you a chance to kind of think about it a little bit. Pause it, think. Okay, so we're going to write this as y equals 3 to the x plus 1. Then we're going to swap x and y. So x equals 3 to the y plus 1. Okay. Now, your job is to get the y by itself. But how? That's the hardest thing right here. Y in this problem is an exponent, the xp. How do you get it out of there? Well, there are two ways. One would be using the Bra-Bar rule. The other way would be to take the ln of both sides. Ln of x equals the ln of 3 to the y plus 1. That gives me the ln of x equals y plus 1 times the ln of 3. Divide the ln of x divided by the ln of 3 equals y plus 1. Where's the glare? Yep, right in the middle of the glare. Ln of x divided by the ln of 3 equals y plus 1. So this tells me y equals ln of x divided by the ln of 3 minus 1. This tells me that this is g inverse of x. This is it. This is my inverse formula, ln of x over ln of 3 minus 1. Okay. Give you a second to catch up. Okay. This is exactly what we were doing when we were solving those exponential equations. Remember I said there's two ways to do them. One way is to use the Bra-Bar rule. One way is take the ln of both sides. Well, I just chose to take the ln of both sides. I'll show you the Bra-Bar way in a moment. But this goes back to what we learned in 10.5. How to solve this problem for y. Take the ln of both sides. And that ugly thing that it is the inverse of that. Okay. What if right here I have y equals 3 to the x plus 1 right here. No, I'm sorry. X equals 3 to the y plus 1. What if I've swapped my x's and y's and are still going, how do I get the y out of there? Well, one way is to apply the Bra-Bar rule. One way is to take the ln of both sides or the log of both sides. It doesn't matter. The ln of both sides, the log of both sides. The other way is to take the Bra-Bar rule. Now, you probably aren't going to like this, but this is going to become log base 3, because remember the base of the exponent is the base of the logarithm of x equals y plus 1. Okay, remember the logarithm equals the exponent. This whole thing was the exponent. The logarithm equals the exponent. So the only thing we have to do is here is take away 1. So log base 3 of x, take away 1 equals y, or to make it look pretty, g inverse of x equals log base 3 of x subtract 1. Okay. So it means that this answer and this answer are identical to each other. And I'm not going to waste your time tonight showing you why and how they're identical. I'm just saying that it's possible that you get, depending on the method that you use, you might get this, your friends might get this, but you're both right. Okay. So here's one of the big ideas. If you start with a function, that's an exponential function. Notice it's an exponent. Its inverse must be some kind of a logarithm. Regardless of the method you use, the inverse was a logarithm. So the inverse of an exponential is a logarithm. All right, I need to erase the board and make room for another example. Anybody have any questions on this one problem? And again, the way I did it, I used 2 different methods. You don't have to use them. Use the one that's your favorite. You don't have to do both, just one of them.
Professor, for the glare,
Yeah.
wouldn't you just like use painter's tape and box it up?
Well, here's the problem, is the glare is coming from my camera. It's shooting out a beam of light here that it's trying to focus on. So even if I put a piece of paper here, okay, wherever the glare is, it's still, when I try to write on that, it's still going to be glared.
So you won't write on.
Oh, I see what you're saying. Well, just put a little thing on there so I know where the hell it is, so I don't write on it.
Yeah.
That's too smart. Maybe I'll do that next week. Okay, that's a good idea. Remind me of that. I'll forget by next week, but remind me.
No
Yeah.
worries.
Okay. All right. Can I erase at least this broad bar example? Is everybody okay with that? Okay. Don't hear anybody yelling. I'll leave this one up. So suppose we had h of x, a new function, equals log base 5 of x plus 2. And I want you to find h inverse of x. Okay, let's take a pause. So let's see, we have y equals log base 5 of x plus 2. Swap them, x equals log base 5 of y plus 2. Now stop and think, how do I get the y out of that logarithm? Raw bar. Okay, the raw bar method. And because it's written backwards, this really bothers people. 5 to the x equals that. They're used to it. They're used to the equation going in the opposite direction. But because it's backwards, people bother with it. It doesn't matter. So this is going to be 5 to the x equals y plus 2. That's the raw bar. So 5 to the x minus 2 equals y. So this is h. Okay, h inverse of x is 5 to the x minus 2. Again, check it out. Logarithms and exponentials are inverses of each other. If I ask you to find the inverse of a log problem, somehow your answer will be an exponential. Somehow. Okay. Let me put up two problems. We'll work on them and take a break. I will also tell you that quiz number 1, there's 2 quizzes. Quiz number 1 contains inverses just like this. Just like this. Okay, so you might want to double check your inverses. I'll talk to you more about, well, a little bit more about what's on quiz number 1 in a minute. I can't even spell quiz, can I? Quiz. What a dip. Quiz. Okay, any questions on at least the ideas that I'm presenting, how to find the inverse? This really puts a stress on you guys because you really have to know what you're doing. Okay, you can't just blindly follow steps. You can down to a point, but right here, okay, I can change the g of x into a y. I can swap the x and the y. But at that point, you have to be able to think about, oh, geez, how am I going to get the y by itself? It's an exponent. How do I get it out of there? So that's where you have to decide, okay, what are you going to do? You have to think. Every problem is going to be a little bit different. So anybody questions on these before I erase the board? Okay. Okay. First problem. Let's say we have f of x equals 3 to the x minus 7. And number 2, let's say we have g of x equals the log base 2 of 3x minus 1. Okay, for both of those, find the inverse. So let's see what I got. Y equals 3 to the x minus 7. X equals 3 to the y minus 7. Okay. So I'm going to call this x plus 7 equals 3 to the y. Remember, our rule is if you got something weird, try and get it as alone as possible. All right. How do I get it alone? Well, one method is bra bar. That would be 3. That would be log base 3 of x plus 7 equals y, or switch that around, f inverse of x equals log base 3 of x plus 7. Okay. The alternate way of doing this problem would be to take the ln of both sides. Okay, so you have the ln of x plus 7 equals the ln of 3 to the y. That allows you to bring the y out front. Divide both sides by ln of 3, so you have the ln of x plus 7. Okay, I'm still safe. Over the ln of 3 equals y, change the y into f inverse of x, and you're done. So even though they look really different, they're exactly the same. Questions on that one? Okay. Then in number 2, we write this as y equals log base 2 of 3x minus 1. Swap them. X equals log base 2 of 3y minus 1. And now think, how do I get the log off of that? And the only way to do it is the Bra-Bar rule. So that's going to be 2 to the x equals 3y minus 1. Remember, the base of the logarithm and the base of the exponent are the same. Also, the logarithm always equals the exponent. The logarithm equals the exponent. So if x is the exponent, there's the exponent. Now all you got to do is get y alone. So add 1, 2 to the x, add 1 equals 3y. There, okay. Divide by 3, 2 to the x plus 1, all divided by 3, whatever that is, equals g inverse of x. Okay. All right, let's take a 5-minute break. Okay, come back and we're going to do word problems. If you didn't have a chance, if you have your home computer and can print something out quickly, there is a worksheet in chapter 10 module. It's called word problems or applications. You might want to print that out. I told you last night, but you're going to need it. Okay, so print that out. Mhm. Okay. Those- Lots of blank space there. Sorry, whoever's watching it. Okay. We're going to be doing for the rest of this evening word problems. Here's the game. I will always give you the formula. You do not have to memorize the formula. I will always give it to you, but you do have to know how to plug numbers in and do the algebra correctly. Okay. In this case, for exponential growth or decay, okay, this is the formula. Now, A of t is the value after some time. That's what A of t stands for. A sub 0, we've already talked about sort of like this. This is the initial value. Okay. R is the interest rate but as a decimal, very important, as a decimal. And T is time. Okay, so I'm going to give you that formula, but you have to know what to plug into it. Okay, and a lot of people keep thinking that this means A times time. No, this is a function. This is A of T, the amount after a certain amount of time. A of T, this is a function of time. So the first problem says a car costs $45,000 new. Okay, so if you don't have the worksheet, I'm going to paraphrase it up here. Car equals $45,000 new, but it depreciates about 7% each year. Okay, so now one of the keys is depreciates, okay, means gets less. To depreciate, you have less. Decay means less. When something decays, you have less of it. And so in this formula, for this problem, we'll use the minus sign. Because the problem has the word depreciate, that means it's getting less value. Okay. This is one formula for either growth or decay. If you're talking about growth, like something gaining value, I think my next problem was about a diamond, how a diamond might gain value over time. Then you would use the plus in the formula and not the minus. But this problem is a decay or a depreciate, so we're going to use the minus. So part A says, what will it be worth? A says, what is it worth in 5 years? So 5 is time. So mathematically, what this is saying is the amount in 5 years, A of 5, what it's worth in 5 years, is equal to the initial value, 45,000, times 1 minus, because we're decaying or depreciating, 0.07 raised to the 5 power. Time is 5. Well, this is just a straight arithmetic problem. This is do it all in your calculator. Okay, this is 45,000 times 0.93 raised to the 5th power. And that's just on your calculator. Come on. Raised to the fifth power. So if you're following along on your calculator, I have this 45,000 and 0.93 to the fifth power is about 0.69568 something. Okay. And again, I'm doing all my work on my calculator. Okay. So I haven't rounded anything. I'm just keeping all the things there. So this is going to be times by 45,000. So I get equals 31305.9766, whatever. But remember, this is money. And money is at worst dollars and cents. Okay. So you might say in 5 years, it's worth $31,305.98. Okay. Again, pay attention. Sometimes it'll say rounded to the nearest dollar. So this would be $306. So that's all just in the directions. But basically, that's all this was, is understanding the formula that if it says decay or depreciates or lessens in some way in value, you use the minus sign. You plug everything in and away you go. All right, part B of this asks a much more complicated problem. It says, when will it be worth 20,000? Now, this is a much more complicated problem. When is it worth 20,000? Okay, much difficult. So wait a minute, 20,000 is what it's going to be worth in the future. We've already seen that in 5 years, it's going to be worth 31,000. So it went from 45,000 down to 31,000 in 5 years. So if it keeps going down in price, eventually it's going to be worth 20,000. So someday it'll be worth 20,000, but it's going to start at 45,000 times 1 minus 0.07 raised to the t power. Because when, okay, when means find time. When implies we're calculating for time. All right, this much more chapter 10 stuff. First thing we're going to do is divide both sides by 45,000. Okay, divide this side by 45,000. This side by 45,000. Okay, so let your calculator do the work. And I get 0.44444444 repeating, whatever, equals 0.93 to the t power. Okay. Once again, we just saw this in chapter 10.5. How do I get this? How do I get the t out of the exponent position? How do I do that? Two ways. You can either bar it, okay, or you can ln both sides. It doesn't matter. Okay, I think I'll ln both sides. So that's going to look like the ln of 0.444444444 equals the ln of 0.93 t. That allows me to have the ln of 0.444444444, whatever, equals t times the ln of 0.93. Remember, by the reason you did the ln to both sides is so that you could bring the t down using a log law. You just can't bring the t down out of the power position just because you want to. You have to have a reason for that. And by having an ln there, you've turned it into a logarithm, which allows you, we have a log law that says, yes, if it's a logarithm, you can bring the power down. So last thing, we divide both sides by ln of 0.93. So we have the ln right there. The ln of 0.4444444, put as many fours in there as you can, divided by the ln of 0.93. That equals t. And so now it's ready for our calculator. So when I do this, I get about 11.17 equals t. So in 11.17 years, car is worth $20,000. Okay. Questions on that? First problem was just arithmetic. Plug in the numbers. Okay. It's just arithmetic on your calculator. Second problem, much higher level thinking. Because when you plug in your numbers, suddenly you have a t that we're solving for, but it's an exponent t. So your job is to think, oh God, how do I get it out of there? ln both sides. Questions, anyone? Okay, I need to erase the board. I'm going to jump down to number 3. I'm going to jump down to number 3. All right, number 3 talks about something called continuous growth. Okay, and it uses the formula a of t equals a naught e to the r times t. Some of you I know many instructors teach it that way, APERT. The amount after a certain amount of time is the initial amount times e raised to the RT. Again, a of t up here, this is the official math way, okay? means just how much is it worth in a certain amount of time. Now, remember, this time is growing, so we're always going to have positive growth. This is only for positive growth. And when it says continuous growth, by the way, this is for almost every life situation, especially though bacteria. Those little bacteria just grow and grow and grow and grow, and viruses, they just grow and grow. So this formula is for something that just keeps growing and growing and growing and growing and never stops, or at least we hope it, we assume it does. So in math, this would be what I write: a of t, the function, equals a naught, or a sub 0, but that is always the initial amount, times e, remember that magic number, the new number we've introduced, e, raised to the RT. All the rules are the same. The R has to be a decimal. Okay, so looking at number 3A, okay, when will there be 30,000 bacteria? Okay. Again, the key word for in English is when, means find the time. So that means time is going to be our unknown, our variable. Okay. And oh, by the way, I forgot to read the problem. It says we start with, I didn't write it down for all you people. It says we start with 20,000 bacteria. Okay, that was in the word problem. If you have the piece of paper, it said that. It says a colony of bacteria starts with 20,000. Its growth rate is 3%. It grows at 3% growth, okay? So eventually, if those little boogers keep growing and growing and growing and doing whatever they're doing, someday we'll have 30,000 bacteria, okay? So when? All right, so taking this formula, we know that someday we'll have 30,000, but we're going to start at 20,000 times e to the 0.03 t. So the amount after some time is going to be 30,000. The initial amount was 20,000. A sub 0. E just stays E. Let your calculator play with that. The rate was 0.03. Remember, we always enter it as a decimal, 0.03. And now your job is to figure out, how do I solve for T? Well, the first thing we're going to do here is divide everybody by 20,000, because we want to get this quantity alone. So 30,000 divided by 20,000, I believe it works out to be 1.5. Okay. I'm going to ln both sides again, because again, always the thing I want, the t, is an exponent, and the only way I know to get it out of that position is to use the log laws to move it down. But to use the log laws, I have to have the ln of both sides. So the ln of 1.5 equals the ln of e to the 0.03 t. So this stays the ln of 1.5 equals 0.03 t times the ln of e. Okay, Now, I hit upon this yesterday. This is a little aside, put it on the side of your notes. The ln of E stands for the log base E of E. When we write the ln of E, it stands for the log base E of E. But we learned in one of our log laws that the log base E of E is always worth 1. One of our log laws said the log base 5 of 5 is worth 1. The log base 10 of 10 is worth 1. So when you say the ln of E, you're actually saying the log base E of E, which always becomes 1. Well, that's kind of cool because that means this part of the problem basically drops out because it becomes 1. Okay. So all I have to do is take the ln of 1.5. I'm going to divide both sides by 0.03 here. And that's going to give me, can it work down there? ln of 1.5. Divided by 0.03. And I get 13.511 something. 13.5, I suppose I should, 155, whatever. Now, hang on a minute. Okay, actually, let me hang on. Any questions about my steps or anything? I'm not done yet. But any questions about any steps I've done? Okay. Question. This is time. I've solved for time. I skipped a couple steps here, but I solved for time, 13.5155. What are my units? Are these years? Are these days? What are they?
Isn't it minutes?
Minutes. That's the key, is you have to go back and read the problem, and it mentioned minutes. Okay, these little suckers grow at 3% per minute. So that's your unit of time. Minutes is times. So in 13.5 minutes, okay, these little suckers will grow from 20,000 to 30,000. Okay. That's called continuous growth. That's the formula. Again, when I give you the formula, use the formula. You don't have to look up anything. My answer key will be based on this formula. Okay, so use it. All right, let's look at 3B, second half. Okay, this is kind of important. This question is going to show up all over the place. And here, just to scare you, this question will also show up on the final exam. Okay, so not only will it be on exam number 3, it will be on the final exam. It'll show up again there. Okay. Part B of the same question. When, okay, will the number of bacteria be tripled? Now, for English, triple means 3 times. Double means 2 times. Okay, so we asked this a lot. When will the number of bacteria, which I didn't spell very well up here, that's wrong, okay, be triple? So this is a little bit tricky. We have this formula, A of t equals A naught e to the RT. We have this fancy formula. We know we're going to start at 20,000 e to the 0.03 t. What do I put over here? What do I put?
20,000 times 3.
Perfect. That's exactly what you put. Because it says these little boogers are going to keep growing and growing and growing and growing and growing. And eventually we'll have 3 times what we had originally. So over here, we'll have 3 times 20,000. Okay. All right. The rest of this problem should work out just like this. Okay. Take a couple minutes, work on it. Okay. So I started by dividing both sides by 20,000 here, 20,000. And it turns out that when you divide 20,000 by, or 60,000 by 20,000, you get 3. That's suspicious. When it said triple, okay, everything canceled to a 3. Think about that. All right, we take the ln of both sides. So we have the ln of 3 equals the ln of e to the 0.03 t. Bring the power down. So the ln of 3, no glare. The ln of 3 equals 0.03 t times the ln of e. Okay. But the ln of e is just a big fat 1. So we have the ln of 3 divided by 0.03 equals t. And I get about 36.6 minutes. Can anybody confirm my answer? And does anybody have any questions on my work?
Got the same answer.
Good. Okay. But all that means is either we both screwed up or we both got it right. So, but yes, it's the same also answer on my worksheet that I did a couple years ago. So I haven't lost it totally. Okay. I want to do one more problem for the night. I am aware of the time. Okay. And I know that I've let us out as early as possible. Okay. I'm aware of the time. I want to do one more problem. It's got 3 parts to it. And then I want to talk about the quizzes and then we're done. Okay. So can I erase the board? Anybody have any questions about using this formula? I'll give it to you. It'll be there. Okay. Then I'm going to erase the board. All right. Last problem of the evening is number 6. Sometimes instead of using these special formulas, scientists have already made up a formula. So this says P of t equals 4.495 times 1.015 quantity raised to t power. Hard to see that little t power. And this stands for the world's population after 1980. And what that means is in 1980, the data that whatever the scientists used, okay, was based upon data from 1980. So T starts at 1980, or this formula starts at 1980. What that means is if I say, what was the population in 1990? Okay, so 1990 minus 1980 is 10. T is worth 10 because it's been 10 years. 1990 is 10 years since this formula was created. So that's what you kind of have to be aware of. Okay. Again, there's the formula. We live with it. Part A says, what was the initial population? Okay. And initial population, initial implies at the beginning. And that means when time is worth 0. Initial, everything starts initially, time is worth 0. So we have P of 0. The population at 0 time is 4.495, 1.015 to the 0 power. Time is 0. Time in the formula is 0. Well, we know that anything to the 0 power is 1. So this is the population when time is 0 is 4.495. And so in 1980, when this thing was first created, the world population was 4.495 billion people. Again, go back. I believe it when you read the problem. Yeah, it says P of t is based upon billions. So some of you could have figured out that 4.495 is the initial amount just because you compared it against previous formulas that we did. But I wanted to use this as a way of, again, discussing vocabulary. Initial means at the beginning, it means time is worth 0. So you take this formula, time is worth 0, work it out, we still get that answer. Okay, that was the initial population. Okay, moving on for number 6. When will the population double? When will the population double? When does population double? So take a second to write the equation. Don't bother to solve it. Just go ahead and write it. just like we did on the previous problem for the bacteria, okay, eventually the population starts at 4.495 and it keeps growing. Eventually it will be doubled. Sooner or later it will be doubled. Okay, so you have this. Divide both sides by 4.495. And you get 2 equals 1.015 raised to the t power. Okay. I'm not going to go through the math. You can take the ln of both sides, or you can draw a bar. That, whatever you do, it's up to you. Okay. The answer that I get for this particular one is 46.555. T equals 46.5555 years. Okay. So that's what I get when I solve it. By the way, if you, I know you can't read this, but if you get this handout off my Canvas site, I believe the answers are there also. Maybe they're not part of this, but it's another link on there that should say answers to word problems. So again, in the Canvas module, chapter 10, the worksheet that I'm doing all these problems on, okay, is there with the answers. I would at least try these before you take any of the quizzes. The quizzes, by the way, aren't due until next Tuesday. They're not due until Tuesday, so you can relax. You can take your time. You can study, work with your friends, call Lisi, practice on the homework, do anything you want. But it's due 6:30. Both of them are due by 6:30 next Tuesday night. Okay, and there is no late pass or anything like that, because you're going to have the entire weekend to work on these. So the last thing I want to do here, is says, what will the population be in 2010? Now, I don't want to do the whole thing, but what is population in 2010? Well, it's a trick question. Okay. What we're hoping that you'll do is you say, oh, 2010. I'll just put 2010 in that formula and let my calculator do all the work. Wrong. When it says 2010, we do 2010, take away 1980. That's when it started, and that makes 30. So for this problem, t is worth 30. Because this problem, remember, started in 1980. So 2010 is 30 years after it started. So if you use t equals 30 and plug it in here, you'll get the answer. And it's pretty accurate, reasonably accurate. It says 7 billion should be about the answer, which is reasonably accurate. Okay. That's a lot that we just covered tonight. And I'm burned out, you're burned out, everybody's burned out. So, quizzes. Both quizzes due Tuesday, 11/16/2021 at 6:30 p.m. Okay. Quiz number 1 you have 2-hour limit. Okay, I don't care when you start it, but once you start it, you have 2 hours. I mean, you could start it Tuesday for all I care. But once you start it, you have 2 hours to do it. It covers mostly chapter 10.1, 10.2, and maybe a little bit of 10.3. The topics in it, and you'll see those much better in a few minutes. You'll see the topics it covers are boom, 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 boom. Function composition, inverses, graph of exponential, and I would encourage you to use Desmos like I showed you last night. Okay, you want to solve same base exponential. And use that formula, future value equals P times 1 plus R over N raised to the NT. Okay, there's going to be a word problem that asks you to use that. So that's quiz number 1. It will have a 2-hour limit. But you can wait and wait and wait. You can do it tonight if you want, or you can wait until Tuesday night. That's totally going to be up to you. But once you start, you have a 2-hour block of time. I urge you not to do it tonight. I urge you instead to do your homework, to practice, to look at the videos, to look at old videos that I put up on Canvas. Okay, look at them. But these are the main topics for quiz number 1. Quiz number 2 is unlimited time. In other words, you could start tonight and keep working and working and working over the weekend and whenever, but it has to be done by Tuesday. Okay. It covers chapter 10.3, a little bit more, 10.4, 10.5, and a couple of these word problems. Okay, so what that means is log laws, okay, where we condense or expand. Okay, what else? Oh, that was 10.4. 10.5 was solving, we just did that tonight, solving exponential equations. Damn it. Or solving log equations, like tonight's lessons. And some more. When you actually open up the quiz is not available to you now. It will be available in 8 minutes, 9 o'clock. If you just go and look at it, I have put a list of the topics much neater and nicer than what I've written up here. But you can't see them now until it becomes available at 9 o'clock tonight. Okay. So the list of topics is much better than what I've scribbled up here, but it's pretty much the same also. Okay, so questions about the quiz. 2 quizzes, both due by Tuesday at 6:30. No late passes. Okay, quiz number 1 has a 2-hour limit. Once you start, you have 2 hours. but you can spend the whole weekend studying, reviewing, working, whatever, before you start. You do not have to do it tonight. Same thing with quiz number 2, except that you don't have a time limit. Okay, again, I would encourage you to do your homework, work with a friend, work with Lisi, whatever. Make sure you understand all this as to the best of your ability. My only suggestion is on quiz number 2, don't think you can do it in 1 hour. Don't think, oh, it's due at 6:30. I'll start at 5 o'clock or 5:30. No. Okay, you'll never make it. Start it Sunday afternoon or Monday. Okay, do something like that. Whatever. Don't run out of time. Start this over the weekend and then maybe study some more, ask Lisi some questions, that kind of stuff. All right, with that, I'm done. Anybody got any questions? No, I've bored you all to tears. You're about ready to quit on math. Have a good weekend, guys. Remember, no class tomorrow. The quiz should be available by 9 o'clock tonight. I will stay online until 9 in case there's a problem. Okay, bye.
Thank you. Have a good one.
You too. Thank you. Bye-bye. Excuse me.